So this problem shows we have this sinusoidal modeling question. So the question is, the high and low points on the track are separated by 50 meters horizontally and 30 meters vertically. So let's just draw a graph to show what it roughly looks like. And the low point is 3 meters below the ground. Let y be the numbers of meters that the track is above the ground, and x be the numbers of meters horizontally from the high point. So we have this graph right here, and 30 meters vertically is like how high is a graph. So we should draw something like, this goes down like this, like so. Right here is 3 meters, but this whole thing right here, this whole roller coaster, let's just say, is 30 meters right here, and this whole length of the roller coaster is 50 meters. So here's the x. Right here would be better. X. And here's the y. So let's write this accordingly to how this graph is. So this, let's just write it in a cosine equation. So y equals cosine. So we need to find the a value. The a value is, let's write this aside. A equals max minus min divided by 2. And the d value is max plus min over 2. So right here, the a value would be max minus the minimum, which is right here. The max is 27, and the minimum is negative 3. Let's add that. So a would be 30 minus negative 3. This will be 30 plus 3, so it would be 33. Oh, my bad, sorry. It's not 30. It would be 27 minus negative 3, which will get 30. So I need to divide this by 2, it will be 15. 15 cosine, and then need to find what's the period, or the b value. So to find the b value, it is from here to here. It's like one whole period. Like for cosine, one period, full period, will be like this, and 2 whole periods will be like this. So since a whole period will be 50, it will be pi over 50 x. There's no phase shift because you start at 0, and then it's plus 12. 12 is the d value, so max minus min will be 27. No, plus min plus negative 30. Negative 3. It will be 24 divided by 2, which is 12. That's the d value. So this is our final equation for a. So we can just graph this into a graphing calculator like Desmos. So switch to Desmos. So y equals 15 cosine pi over 50 x plus 12. So right here we only have one period. That's like what's graphed. So we can just go to here, x, you can just have it at 0. And we wanted to have like a bit showing more than 50. So let's just say a value like 80. Y-axis. So if you have like negative 3, it's safe to use like a bit more, so we can use negative 5. And since it's like 27 meters vertically tall, we can just use like 35. So this is the graph, like how is it supposed to look? So the first question asks, how long is the vertical timber at the high point? So at the high point, it asks like how high is here. So the high point is 27 meters tall. So let me just clear everything. So right here we have this. So let me just draw another graph right here. So it starts right here at the high of 27, as you can see from the graph. So it just goes here, down like that. So this is -3 at this point, and this high of 27, this total is 30 meters. And right here is 50 meters. So this high point, B, is 27. So that's only the first part. The second question asks is, what is x at 4? So let's just move back to the Desmos. So we can just plug in x equals 4. And let's see what's the value is. 26.529. So x equals 4. We can just write it like 26.529 at x equals 4. This is like one way how you can express it, and it's always good to keep at least like 3 decimal places when it comes to graphing. Let's see, x equals 32 meters. Switch back to Desmos. So it's 32. It's right here. It'll be 5.613 meters tall. So 5.613 at x equals 32. So that's all we need for B. So how long, for number C, is how long is a horizontal timber that's 25 meters above the ground and 5 meters above the ground. So the horizontal timber is like this on the graph. So you're trying to find like how long is it at 25 meters. So we can just switch to Desmos. So right here, instead of using x, we're using y. So y equals 25. So the x will be how long the timber will be, and it'll be 8.313 meters. Alright, for number C, since it has like how long was the timber at 25 meters, we can say 25 feet, or y, at x equals 8.313. So now we're finding how much is 5 meters. Switch to Desmos, and then x equals 5. Timber is 32.727 meters long. So 5 at x equals 32.727 meters. Or I feel like another way you can express this answer is just like simply just put x equals 8.313 or x point equals 32.727 meters. Yeah. And lastly, number D asks, where does the track first go down? So we're going to find this point. So D. So this point is basically the x-intercept. And you can just go to Desmos and just find where's x-intercept. And the x-intercept is at 39.758 meters. So say at 39.758 meters, which is x. So right here we have this another patient, and her name is a patient has cancer. So she must have chemotherapy treatment once every 3 weeks. One side effect is that her red blood cell count will go down and then goes up between treatments. On January 9th, the 9th day of the year, she gets her treatment. At that time, her red blood cell count is at a high of like 800. Halfway between treatments, the count dropped to a low of 200. Assume that the red blood cell count Y varies sinusoidally with the day of the year T. So the first question asks to develop an equation that models the above behavior. So sinusoidally just means that it varies like this, like it's always consistent. So we should first develop an equation that graphs this. So let's just draw this out first. We can just skip to B first. Alright, so if you have a red blood cell of all time, like high of 800 and low, 200. Graph that like that. And she gets her treatment on day 9, which is January, so just do 9. In 3 weeks, like it's 21 days, so we on day 30 where she get her next treatment. So she gets the low of red blood cells in between, which is between the 21 days, it'll be 19.5 days. So 2 full periods just be maximum to maximum, here to here to here. Wait, actually, I might want to draw this. Do it like this. Here. That's good. This graph just goes down. This side also goes down. So if you want to write the equation out, it would be y equals. So to find the a value, it would be maximum minus minimum. It would be 8 divided by 2. So 800 minus 200, which is 600 divided by 2, equals 300. Because 600 divided by 2 would be, yeah. So 300 cosine. And then, since this is 2 periods, like we need to do 2 pi, because that's what 2 periods represents. So 2 periods is 21 days in this case, so we can just do 2 pi over 21, and that should work. And then we have x minus 9. So 9 is a phase shift because that's like where the graph starts in, yeah, the 9th day of the year. And plus d. To find d, you need to maximum plus minimum divided by 2. So this is 1000 divided by 2 is 500 plus 500. So this should be the formula we need. So just plot this into Desmos real quick. So we got y equals 300 cosine, parentheses 2 pi over 21, x minus 9, and then we got plus 500. Yeah, this should be pretty much accurate, just in a smaller scale. So since we're only looking for 2 periods, I mean, we can just do a bit more. So right here, axis, we can do like 0 will be fine. We can do it up to, let's say, 50 days. X, we can do negative 100 to 1000. Alright, from here, this is what the graph should look like. Not like, I mean, like earlier when it has like those really tight lines, just the scaling is a bit different. So right here we have already finished the first 2 questions. Draw a graph that has 2 sinusoidal periods. And number C, we need to figure that out. So February 7th, her birthday, would be so January have 31 days, plus 7, it will be 38, the 38th day. So we can just switch to Desmos real quick and find the 38th day. It would be, so the time would be on the x-axis, so x equals 38 right here. So on her birthday, her blood cell count will be 280. It wouldn't really be like 0.084 because you can't have 0.084 blood cells because blood cells is like a counted thing. So for C, that's her birthday, her blood cell count will be 280. And IMA feels good if her red blood cell count is 700 or more. She feels bad if the count is 300 or less. After her, well, it'd be her, not he. Her her first treatment, identify the days when Amma feels good. Amma feels bad. So from there we can switch to Desmos. So we're looking for days where she feels bad. So just like an interval. So right here, the y-axis would be her blood cell count, red blood cell count. So y equals 300 will be the interval that we gotta look at. So since like the day 9 will be right here, after her first treatment, on the days that she'll feel bad is on day 16 and day 22. Like halfway across day 16, it's like 16.689. Okay. So under D, so identify the days where Amma feels bad. So it's the days where like her first time, like when it dips down after 9, it would be days 16 to 22. Or to put this more accurately, it can just be January 16 to January 22. And that's your answer.